What if I told you there might be a single elegant principle that explains everything from the very first living cell all the way up to your own conscious mind? A theory that connects the fundamental physics of just existing with the act of thinking. Well, today, we're diving into a pretty radical idea that attempts to do exactly that.
It all really starts with this deep question from the physicist Erwin Schrödinger, asked way back in 1943. He was basically asking, what is the physical spark that separates a living thing from, say, a rock? How do living things manage to defy the universe's constant, relentless pull toward chaos and disorder?
So, how do we even begin to tackle Schrödinger's massive question? We're going to unpack a theory that suggests existing and thinking aren't two separate things, but actually stem from the very same fundamental drive.
To get there, we actually have to start with an even simpler question, something really fundamental. What is it that truly separates you from everything else, from the chair you're sitting on, the air you're breathing, the rest of the entire universe?
The answer, according to this theory, is a boundary. But not just any boundary. It's a very special, specific kind of barrier that's the absolute first ingredient for life itself.
That boundary has a name. It's called a Markov blanket. Now I know, that sounds super technical, but the core idea is actually pretty intuitive. Just think about your skin. It separates all your internal stuff from the outside world, right? A cell has its membrane. A Markov blanket is basically the statistical version of that. It's the conceptual barrier that insulates a system, like you or a cell, from all the external chaos of the universe.
So how does this blanket actually work? See, it's not a solid wall. It's an active interface with two crucial parts. You've got your sensory states. Think of these like your eyes and ears. They take in information from the outside world. And then you have your active states, like your hands and your voice. They allow you to act on the world based on what's going on inside you. And what this creates is this beautiful perception-action loop. It's a two-way street. The world pokes you, affecting your internal states through your senses, and your internal states poke back, affecting the world through your actions. This constant back and forth is the fundamental basis for how everything, from a tiny bacterium to you, interacts with its environment. Okay, so we've got a system, and it's defined by this active boundary. But what does it do? The theory proposes one incredibly simple, powerful rule that governs any system that manages to stick around over time. This rule is called the free energy principle. Now, for a moment, let's just forget the term free energy. It's a technical thing from thermodynamics. What you really need to know is the core idea. To stay alive, a system has to minimize surprise. And surprise here is just a fancy word for the gap between what a system expects to happen and what it actually senses. You can just think of it as prediction error. So why is minimizing surprise so important? Well, think about your own body. Your temperature has to stay within a super narrow, predictable range, right around 98.6 degrees Fahrenheit. Any big deviation from that, a high fever or hypothermia, is a huge, dangerous surprise. So to survive is to constantly act in ways that keep your internal world predictable. At its core, existence is a constant battle against surprise. So if the main goal is to keep surprises to a minimum, how does a system actually do that? Well, this single drive to minimize prediction error gives rise to two very familiar abilities: perceiving the world and acting in it. The whole process is called active inference. Okay, let's break this down. Imagine there's a mismatch between what you expect and what's really happening, a surprise. You basically have two options. Option one, you can change your internal beliefs to match the world. That's perception. For example, you feel a raindrop. Surprise. You update your model of the world. Ah, okay, it's raining. Option two, you can change the world to match your beliefs. That's action. You believe you shouldn't be wet, so you act to make that true by opening an umbrella. This sets up a non-stop loop. Your brain is not just a passive receiver of information, it's a prediction machine. It's constantly guessing what sensory signals it's about to receive. When reality doesn't line up with the guess, that creates a prediction error or surprise. And the brain's entire job is to resolve that error, either by updating its prediction, that's perception, or by taking action to make the world conform to its original prediction. So this seems like a pretty neat way to explain how we think and act. But remember, the theory claims to be much bigger than that. Can it actually explain the origin of life itself? Let's look at a couple of wild simulations that put this idea to the test. In this first simulation, researchers basically created a digital primordial soup, just a chaotic mix of virtual particles bouncing around. And what happened was remarkable.
Out of pure chaos, some of these particles spontaneously organize themselves, forming a stable boundary, a Markov blanket. This little protocell then started acting in ways to maintain its own structure, essentially perceiving its environment to survive.
And here's the real kicker. When the researchers digitally broke that boundary, the whole structure just disintegrated. It fell apart. This proved that the boundary wasn't just some passive container. It was the very thing that enabled the system to exist and fight off disorder. This is self-maintenance, or autopoiesis, in action.
Now let's jump from the dawn of life to something way more complex: handwriting. In a second simulation, an AI agent was given an internal model, an expectation, of the muscle sensations that happen when you write. To minimize its prediction error, it had to act. Its arm began to move simply to make the incoming sensory data from its muscles match its internal prediction. And in doing so, it wrote a letter. Action is literally just fulfilling your own prophecies.
But this is where it gets absolutely mind-blowing. The researchers then just showed the agent a video of someone else writing. The agent couldn't move, it wasn't getting any muscle sensations, and yet, to make sense of the visual input, to predict and understand what it was seeing, it activated the exact same internal model that it used to write for itself.
This reveals what might be the theory's most profound insight. The neural machinery you use for doing something is the very same machinery you use for understanding it when someone else does it. Doing and perceiving, action and understanding, they're two sides of the very same coin, both driven by this fundamental need to minimize surprise. This could be a powerful physical basis for things we observe in the brain, like mirror neurons.
And that brings us full circle to this final thought from the physicist Hermann von Helmholtz, who was a major inspiration for this whole line of thinking. We don't just passively see the world, we actively probe it. Every single move we make is like a little experiment designed to test our models of reality. From the very first cell clinging to existence in the primordial soup to the most complex human thought, life itself might just be this continuous, beautiful process of making sense of the world by trying to be less surprised by it.